even the latest fruit phone. The fast charging speed is only 20 W. The fast charging speed of domestic phones has reached 100 W. So, how is fast charging actually achieved? Why is the fast charging of domestic phones so much faster than Apple's? Why are fast charging solutions from different brands incompatible with each other? In this video, we will help you understand it all at once. There are many types of fast charging. Let's take PD fast charging as an example. Let me explain its charging principle to everyone. The full name of PD fast charging is USB power delivery, which means USB power transfer. It is currently the most mainstream and universal fast charging standard. Currently, PD fast charging almost exclusively uses Type-C interfaces. You can take a look at the USB-C port's pin definition. These are all pins related to communication. Let's not worry about that for now. In fact, only these 8 pins are responsible for transmitting power. Moreover, the 4G end and 4V bus are internally connected. Essentially, it is equivalent to 2 pins. With these 2 wires, the battery can be charged. However, at this moment, only low power transmission is possible. You might have a question at this point. At this time, directly increasing the voltage or current of the pins, wouldn't that make charging faster? This is a very crucial question. For example, traditional USB devices are said to only accept a default of 5 volts voltage. But now many chargers can output up to 20 volts. And the connectors are the same. If a charger set to output 20 volts charges a 5 volts device, it can easily lead to issues. To solve this problem, the USB-IP Association added CC pins to the Type-C port. To achieve reversible insertion, 2 CC pins were added. But their essential function is the same. Whoever connects is the one that works. Communication between PD fast charging relies on the CC configuration channel pins on the USB-C port. When first connected, the charger sends its capability list to the phone using the CC pins. This is referred to as PDO, or Power Data Object. In other words, it tells the phone what power configurations it can provide. Then the phone selects a configuration that it can accept. For example, 9V3A. Only after a successful protocol handshake does it switch to the target voltage. The phone determines how many watts, volts, and amps to use. The charger is merely a tool that provides multiple options. It will not actively push power. Thus, even if you use a 240W PD charger, as long as it is compliant, to charge a 27W phone, the charger will only output 27W of power. It will not harm the phone's battery in any way. The entire process is completed in a few hundred milliseconds. So after we plug in the fast charge, we need to wait for a short period. However, earlier non-fast charging devices did not have the complex PD communication, so they could charge quickly once plugged in. Therefore, to use PD fast charging, in addition to the necessary power pins, the participation of the CC pins is also required. Let's take a look at the PD fast charging cable that comes with Apple. In addition to the CC pin, there's also the DD pin. The DD pin is the USB 2.0 data pin. Therefore, the cable that comes with the iPhone can only support low-speed data transfer. Now, looking at this fast charging cable from Xiaomi that I have in hand, I'm not sure about the others. It has 3 fewer pins than Apple's, but the effect is the same. This is because the USB-C port is symmetrically designed for reversible insertion. Therefore, the roles of the upper and lower pins are the same. This way, the Apple cable can provide PD fast charging for Xiaomi. The Xiaomi cable can also provide PD fast charging for Apple. So far, PD fast charging can support up to 240 W of charging power. When the PD 1.0 protocol was first released in 2012, it supported fast charging up to 60 W. Even so, why do domestic manufacturers rarely use PD, and instead develop their own proprietary charging protocols? This is due to the contradiction between PD fast charging specifications and mobile phone charging needs. PD generally adopts a high voltage and low current scheme. For example, this iPhone 16 Pro has a charging voltage of 15 volts. The current is only just over 1A. The original intention of the PD protocol is to serve high-power devices like laptops. It is not solely developed for mobile phones. This is because mobile phone batteries have a very low voltage. Typically, it is around 3.7 volts to 4.5 volts. If it receives 15 volts or even higher voltage, this would require additional voltage reduction circuits. This process will involve energy loss, and energy is lost in the form of heat. Mobile phones are already compact in size. They cannot withstand much heat. Therefore, early mobile phone PD fast charging had low power. Thus, mobile phones are more suitable for low voltage, high current solutions. Domestic proprietary fast charging protocols are designed based on this concept. For example, in 2014, when mainstream charging was still at 5W and 10W, the VOOC protocol of OPPD Find 7 jumped to 20W in one go. The industry was shocked. It completed all voltage conversions within the charger. It directly reduced to around 5 volts. There is no need for further voltage conversion on the mobile phone side. It avoids energy loss during the secondary voltage drop at the mobile end. Thus, it reduces heat generation. This part of the heat will be borne by the charger. Therefore, chargers using a low voltage, high current scheme generate more heat correspondingly. As the mobile phone does not require a voltage drop, the amount of heat generated is less. This allows for a larger current to pass through. This increases the charging power. In the charging cable, Type-C uses thicker copper wire. Thus, it supports 4A or even higher currents without causing overheating. Aside from the differences in voltage and current specifications, domestic proprietary fast charging protocols generally use 2 battery cells. For example, 2 battery cells in parallel. This can withstand higher currents. Currently, these domestic proprietary fast chargers are essentially similar. They all use low voltage, high current, dual battery cells, and thicker charging wires. The most essential difference is that the communication methods of the private protocols are different. This information is not public. So if the pins of the charging cable can align with the internal wiring, can they be used interchangeably? They can be used, but only for slow charging. This is because current super fast charging cables all have identification chips inside. Only after passing validation through this chip, will the charger output a high current to the phone. The fundamental purpose is to prevent users from using inferior charging cables. Open black lens bracket, which could lead to fires. Currently, Apple still uses the most basic PD fast charging. Therefore, it cannot be compared with domestic proprietary fast charging. Because proprietary fast charging differs not just in protocol, but also has undergone exclusive customization at the hardware level. With the release of PD 3.0, PPS, or Programmable Power Supply, was introduced. Open black lens bracket, which is a programmable power supply. PPS supports more precise voltage regulation. It adjusts between 3.3 volts and 21 volts in 20 millivolts increments, rather than the previous fixed levels of 5 volts, 9 volts, 15 volts. And it supports a maximum current of 5A. For example, directly outputting a voltage of around 4.5 volts. Enables direct charging of the battery. The phone does not need significant voltage conversion. Heat generation is significantly reduced, particularly suitable for use while charging. Domestic manufacturers did not adopt the PD protocol early on. It is not only due to historical, technical control, and ecological reasons. It is also closely related to the fact that the voltage and current specifications of PD fast charging are not suitable for direct phone charging solutions. In recent years, the PPS introduced with PD 3.0 has become stronger. Many manufacturers have started to support the PD protocol. However, to differentiate, proprietary protocols remain dominant, because they can achieve higher power and better optimization. This is my understanding of fast charging, and I hope it helps you.